Good afternoon, everyone. I'm Jash Mistry, joined here by Gabriela Medvetska. We are full-time software engineers and the site reliability engineering team at eBay and part-time amateur chefs. I'm sure a lot of the people in this room are also amateur chefs, constantly trying to perfect how do you serve up consistent experiences to your customers through while interacting to your applications, making sure these experiences are available, reliable, fast, and most importantly, delicious. So, and most of us here will also be working with very similar common ingredients in Observability, your metrics and your dashboards, and are also well-known and well-documented across our industry that service-level objectives or SLOs are the secret sauce which really brings observability and monitoring together. So today we are going to share a recipe with you, which will help you with defining SLOs to ensure asynchronous applications are well monitored and the experiences that we are providing through asynchronous applications are consistent. So the title of our presentation is going to be Beyond Sequential, a recipe for async pipeline, observability, and alerting. So here's a quick overview of our recipe. So there are three main sections to it. The first one is preparing our ingredients, gather your application, your metrics, and then once you have that, boil them, mash them, stick them in a stew, create SLOs and meaningful dashboards out of those metrics, and finally, garnish and serve. Once you have your SLOs, how do you maintain coverage and compliance when over all these SLOs and the things that you have developed out of the previous steps? So let's talk a bit more about the first step in the recipe, which is preparing our ingredients. So the main ingredient here, of course, is the asynchronous application. It's also important to note that asynchronous applications are not rare in our organizations, right? All organizations will have some use cases where you really do not need to respond immediately to a request. You can just have a case where all the requests are collected, you do a fire and forget and move on with the rest of the experience and only worry about the results once they are ready, right? It's a very common use case that we will have across our infrastructure. So they're not rare. There'll be other use cases too, which are not time sensitive either. So you'll have multiple asynchronous applications throughout your infrastructure. Once you have that, the next essential for making observability recipe is, of course, the metrics. You cannot have any observability without the metrics. So you need that. And on top of that, you need to create a dashboards and your visualizations, which inherently also means that you need query capabilities on top of that. And finally, once you have a good visualization of what metrics you want to monitor and look at for your asynchronous application, you need to define your good and valid events. And here, if anyone who has worked with SLOs or went through the Google SRE book, which initially introduced SLOs, you would know what valid events and good events are. So you need those definitions before we go into defining SLOs. And finally, once you have that, you have SLOs on top of the good and valid events. First, I've used the word asynchronous multiple times, so I'm just going to spend some more time on making sure that what I mean by an asynchronous application. I'm sure all of you will have a general idea, but I just want to spend some time, give you an example at eBay so that we have a clear understanding of what I really mean when I say asynchronous. So before I go into the example, I'll give you some background to how the item recommendation system at eBay works. So that's the example I'm using to explain what an asynchronous application is. So item recommendation, as the name suggests, is just giving you recommendations of items after you finish your checkout. And before we introduced a ML-based item recommendation system, years ago. This is that we didn't have a ML-based item recommendation, but after a user went through the checkout process, bought an item or added an item to a wish list, we just showed a list of items which were trending in the categories of similar items. And if you compare like the monitoring impact of showing just top items from a top trending item from the same category versus showing an ML-based recommendation of the items that the user can buy after going through the checkout process, we saw that the revenue difference was at least 2.1%, like after we introduced the ML-based recommendation algorithm over the old system. And I wanted to emphasize this specifically because when we generally say asynchronous applications and processing things offline, we don't really always consider them to be like top priority or being very business impacting. But as the number 2.1 suggests, that's a significant amount of revenue, and that's why it is important that we have a good solution in place for monitoring asynchronous applications. So yeah, let's go into the example of how the item recommendation system works. I'll be very brief and vague about how this works because that's not the crux of our presentation, like what the ML algorithm is, but it's just to illustrate like what asynchronous application is and how can we create our monitoring solution on top of this. So first, we have the producers here. I say producers because essentially they are just regular sequential synchronous services or APIs where users interact with on a UI via their APIs for buying an item or adding an item to a watch list. They're just request response systems. They have no asynchronous nature in their use cases. But what they do is when a user buys an item, they produce a message, or the nomenclature we also use is drop an event into a queue. This event is called the seed item queue. And what each event or each message will have in its payload is the ID of the user who bought an item or added an item to a watch list, and the item ID of the item which was bought. Finally, from this queue, we have the async ranking service application. This is the application that we are developing a solution to monitor. So this is the main consumer, which is going to consume these events or messages being dropped into the queue by the producers. And this consumer can be compute driven, or it can also be IO driven. Like it can totally just be a pass-through which just calls external APIs, or just databases and so on. So here in this example, the consumer calls the ML recommendation API. And as with any API or network call, there is also a chance that due to a transient issue that the call did not go through. So the platform on which asynchronous applications are developed at eBay also inherently supports a retry queue. So let's say if the consumer is trying to consume an event and the API needed to consume that event successfully did not go through, it is automatically added to a retry queue, and the consumer has the capability to read from either the retry queue or the main queue per se. And finally, after the processing is done, it is written into a ranked items database, or we can also call it the consumed events database. That means that the consumer has done its processing and has written its final result into this ranked items database. An example in our item recommendation system, how this would look like would be that for a user ID, this is a list of all the items that the system returned with, like a list of item IDs, for example. That could be what will be written into the consumed events database, which is eventually ready to be consumed by some other service, like the recommended items page. So the next time the user comes to eBay or goes to checkout, this is where that service will look into the database, where the service will look into to populate a list of items, recommended items for that user. So yeah, now that we have a general understanding of like how our of how our asynchronous application works and like what are we trying to monitor, the next step is how do we define service level indicators for all of these things which are working to get our item recommendation system in progress. So these are some examples of SLIs. It's not an exhaustive list. So I'll go over them and explain them in the context of like how we are monitoring the item recommendation system. So the first couple are availability and latency. This very straightforward. Like if I have to give you a quick analogy with synchronous application, is just the rate of 5-6 responses or the rate or the duration of a request. The definition of the availability and latency SLIs will slightly vary for our asynchronous application compared to like synchronous applications, and we'll go over what these variations are and how do we actually define for in our use case later in this presentation. But before that, there are also some other SLIs you can have for your async applications. The one is freshness. Freshness is basically, let's say that the recommended items, like the relevance of the recommended items are about like, the recommended item is relevant, which was relevant 30 days ago, but not relevant anymore because the user has gone away from that category. So basically the recommendations are not fresh anymore. Like that is one way of looking at it. The next is quality. It can be that the recommended items list could have been way larger. It could have like more accurate items in the list, but for whatever reason, the application was not able to provide that accurate list, and it just gave like 1 or 2 items. So that can be measured through the quality SLI. Finally, throughput is just nothing but the number of items which are processed within a given amount of time. If for our presentation and like what we have developed at eBay, we only focus at the first couple SLIs, availability and latency. There are 2 main reasons why we went ahead with availability and latency. First is criticality. So if you think about it, if you can effectively measure availability and latency, you can kind of derive the other 3 SLIs out of it. For example, quality, you can define your availability in a way that a bad quality is considered to be a failed response from the application, right? And similarly, freshness and throughput can be derived from latency. Like for example, if the consumer took really long to successfully consume an event, that actually also means that the output from the consumer is not really relevant or not fresh anymore. Similarly with throughput, like the longer it takes, the lesser the throughput of the application will be. So yeah, so that's why we went ahead with availability and latency. So first, let's talk about the availability metric, how do we define the metric on top of which we are going to define our SLIs. So every event that comes into the async application has 3 possible states: success, abandoned, and retry. And this is common across our entire platform. So like any developer who is developing an asynchronous applications get these out of the box: success, abandoned, and retry. Out of this, retry is a transient state. So basically, if let's say if there is a transient network failure while calling an external API from the async application, right? So that event is added into a retry queue. And we also have configurations where you can define the length of the retry queue and like the number of times the event can be retried before it is eventually marked as abandoned. But yeah, that's important because retry is not a final state. Like eventually every event will be either success or abandoned because there is a maximum number of retries an event can go through. But eventually it has to be converted into a success or a abandoned state. And what does success and abandoned state mean? It's very straightforward. Like you define what is a successful way of processing an application event by the application, or like what is a failed or an abandoned definition of what an event is defined as in the asynchronous application. So now that we have a good understanding of what the availability states are, how do we define a metric and an SLI on top of it? So we just use a Prometheus counter to pretty much mark whether our events are marked as success or abandoned. So here, if you look at the query, the consumed item count is the name of the counter. And you have other attributes in the labels which helps us to, since like these are also metrics which are available out of the box in our platform. We have labels to query these metrics specific to a consumer name and the event name. And the label which is more relevant and important in the context of the presentation is the status label. You can see status is equal to success. So essentially what the top query really means is the number of successful events which are consumed by the ranking consumer, and the event is ranked seed item in a given unit of time, that is per second. Similarly, if you look at the bottom query, it is for the most part the same, but the status you can see like we have success or abandoned. And as I mentioned earlier, all events eventually can only have two final states, success and abandoned. So this query gives us the total number of events which are consumed per second. And yeah, as I mentioned earlier, if you're familiar with SLIs and SLOs and have worked on defining them, this is the basic definition that we use. The ratio of good events over valid events consumed in a given amount of time. And here, the definition of good and valid events changes from case by case. In this case, it is whether the final state of the event was success or abandoned. So that was how we defined the availability SLI. So now let's talk about the latency SLI. And before that, how do we calculate the latency metric? So we use Prometheus histograms to make our calculations on the latency. And how we eventually calculate this. So for example, let's say our producer, which was the service which goes through the checkout or the adding an item to a watch list service, it writes the event into event queue, the seed item events. The asynchronous ranking service application then reads this event from the item queue, and let's say the event spends some time in the queue, right? It does not go into the application immediately. It spends some time in the queue. So we also add that, let's say it spends 10 milliseconds. So we also add that to our calculation. Finally, for whatever reason, let's say it did not succeed in the first attempt. So it went to a retry queue. It spent some time in the retry queue. And eventually, the async ranking service picked it up from the retry queue, consumed it successfully, and it was finally written with a success state into the final consumed events data store. So at each stage, we calculate the timestamp and we add that duration into our Prometheus histogram measurement. So for example, in like here, every stage 10 plus 10 plus 10 plus 30, we make the total calculation as 60 milliseconds, and that's what we store in our histogram. So yeah, that's how we define the latency metric. Now let's talk about how we define the SLI on top of the latency metric. So if you look at the queries, you'll see they are very similar to the queries that we had for the availability SLI. The only difference here is the LE label. So back there, it was status is equal to success. Here, it's LE is equal to 10,000. So what essentially changed here is the definition of a successful event. There, the definition was an event which ends with the status as success. But here, the definition is an event which was consumed within 10,000 milliseconds or 10 seconds. So that's a label which comes with the Prometheus histogram. And we use that to define the good events for our SLIs. Similarly, the bottom query here is the total number of events consumed per second. So the difference here is LE is equal to plus INF. So plus INF basically means plus infinity. So in the histogram, it gives you the total number of events or the calculations which were made within the entire latency histogram range that we had configured. So that's how we get the latency SLI.
gathered metrics and SLIs to essential ingredients. What's that?
Mic. Test.
Oh, okay. Now that we have gathered metrics and SLIs to essential ingredients needed for our recipe, it's time to spice things up with custom dashboards. So on the screen, you see examples of the panels we use to monitor our sync pipelines. So even without SLOs, we look at event status, consumer backlog, and retry backlog, which are basically availability metrics. And then the producer to consumer, as the name says, 99 percentile latency would be our latency metric. So these can be used on their own as like in regular day-to-day SRE flow, but it is definitely more efficient to onboard SLOs and have alerting systems on top of these to make the most use of it. And as SREs, we take risks all the time. It is whether it's monitoring a new feature in production or implementing a major infrastructure change, we are at the forefront of sites reliability, and it is our responsibility to make sure that we have the safety nets in place to allow for experimentation, such as new features or changes, and protecting sites reliability at the same time. So one way to achieve that is to define SLOs and let them handle the heavy whisking. So we kind of brushed over the SLIs and availability metrics and all of those things, but here are the actual definitions. So SLO stands for service level objective. It's the internal promise to meet customer expectations. It sets the target of an SLI over a period of time. An SLI, you've heard that so many times at this point, is the service level indicator. So that's a metric that we're keeping track of. Here is an example of an SLO definition, such as 99% of events over 30 days should be processed within 10 seconds. 99% is the SLO goal, 30 days is the SLO period, and 10 seconds is the SLI metric, in this case, latency. What happens when we receive dozens of emails, Slack messages, false positive alerts, metric alerts, maintenance alerts, Jira notifications, regular work emails, all requiring our attention? We burn out. Fortunately or not, we as humans don't have chips embedded in our brains to help us process more information. So as such, we need to balance our flavors and prevent alert fatigue. Using foolproof, error budget, and burn rate alerts, we can make sure we're able to handle the alert heat. So some more definitions, and this part of the presentation will be a little heavy on a lot of text. But error budget is the number of errors accumulated over a certain period of time before your services go out of compliance. So it's defined as budget of unreliability equals 100% minus the availability target or latency target or whatever SLI you defined target. That means that if you have availability target as 99%, your budget of unreliability is 1%. Basically only 1% of requests are allowed to be unreliable or out of the bounds of the defined thresholds for that compliance period, so usually 30 days. So if we defined it as like 99% of events over 30 days within 10 milliseconds should be processed, that means only 1% of requests are allowed to be longer than 10 milliseconds. And burn rate stands for how fast relative to your SLO, your service consumes the error budget. So these definitions help us understand how to set up the alerting, because like all of these are defined in the Google SRE book, and you can read a bunch of stuff about this there. We are here just mostly providing an overview how we have implemented it and how we have used these particular concepts for defining async SLOs. So burn rate here on the chart would mean that if an SLO has a burn rate of 1, then it would just like gracefully run out of the error budget within 30 days, while the burn rate of 2 would mean that it runs out of budget within 15 days, and burn rate of 10 in about 4 days. And why the burn rate is important is because it's used in the formula to set the alerting. And the concept introduced by Google is multi-window, multi-burn rate alerts, which help you prevent false positives and still have sufficient visibility into services performance. So it's basically time boxing the alert within a specific window to help it resolve faster and not keep alerting once it's already fixed. So make sure to season your alerts to taste, but remember that overdone notifications are just as bad as undercooked monitoring. So you really want to find a good balance between false positives and still be able to get an alert when something is going on. So for instance, if we combined a 6-hour window with a 30-minute window, then when the 6th window is threatened, we would get an alert, but it would resolve quickly after the fix when the 30-minute window is already in the green. This all depends on the burn rate. So here, burn rate, the formula for burn rate would be budget consumed times compliance period divided by alerting window. So if you want to get an alert when the 2% of error budget is consumed, so within the previous slide, that would be like before 5, obviously. So you would want to, that's when you want to get alerted. You would want a burn rate of 14.4, and you would get there by taking the error budget consumed, multiplied by 720 hours, and then divided by 1 hour because it's your alerting window, you would reach 14.4. For purposes of our async pipeline SLO observability, we chose the last 2 selections in this, like the multi-window alert systems, and we chose the 2-hour and 1 day for critical notification, and then the 6-hour and 3-day for warnings. So the burn rates there are 1 and 3, respectively. And to show you how that looks like, so this is basically the alerts we have defined. So this is an availability alert. The 0.144 is the burn rate of 14.4 times the 0.1% error rate. So these are basically the hours, the times, the windows for our alerts. And we have also added the consumer down and data loss alerts to make sure that the metrics are flowing and present, because we don't want to get a bunch of no data on our dashboards. And so we have alerts set up for that. All right, now that we have SLOs defined and we know what they stand for and how alerting there works, it's time to harness the SLO metrics. Unfortunately, this was all references to dunes and sandworms, and metrics flow was spice flow, and this was harnessing, and we were supposed to have the Paul Atreides on the sandworm here, but to avoid any sort of issues, we decided to keep it simple, and it does not have the. And I'm really sad about it. I just had to communicate that. But anyway, so we're harnessing our SLOs metrics. And once here are some examples of basically what we would have. So in addition to just having the regular latency percentiles and error rates and status, we would have the last 7-day performance. So basically taking our Prometheus metrics and counting, checking how the service is performing over the last 7 days. Then we have the SLI success rate, so basically the SLI availability metric or a latency metric as a success rate, and then monthly error budget burn rate. So that's basically the same burn rate chart over 30 days, but in this case plotted on the actual how the service is performing. And then the daily SLO performance based on error budget, which shows how there is a daily error budget allocated and how each day the service is doing compared to it. And this way we could directly see that there was something going on between February 24th and February 28th or something. And then some other days it might have just been having greater latency, but it was still okay, and it was not multiple days in a row that the service was violated. But even then, you might have received an alert then, but overall the service is still in compliance and has enough error budget to not be out of compliance. So these metrics really help to visualize for you as like to keep track of what's going on with this SLO and how changes or service or site incidents impact the service overall. So to take your async observability from basic ingredients to a gourmet experience, we suggest the following serving suggestions. So you can garnish your SLOs and SLO triage assistant. As you've seen, there are a lot of companies here at the presentations booth that have provided various solutions for that. So that's one way to then take SLOs further. So you can let AI handle the first taste of alerts, preheating the kitchen and providing necessary context to your chefs. Another one would be folding your SLOs into CI/CD pipeline. You could automatically block rollouts when SLOs run out of compliance or latency availability issues for investigations are not being addressed within a month or so, or you can define 3 months, just like the previous presenters from Meta were saying for governance, they had specific policies, right, that they make services adhere to. You could do the same things with SLOs. And for that, you would define coverage and compliance. So you would ensure that your entire service menu meets the organization and availability goals, and you could define specific standards, like this is how much traffic coverage we want for SLOs to have, this is how much compliance there should be across all of the SLOs for the whole org. Now that we've covered that, we can talk a little bit more about like how we have found SLOs to be helpful for our systems. So this is one example where we got a Slack alert, and then right after, we just directly look at availability SLI for a consumer dashboard, and we see that there was a deployment in downstream dependency right before SLO started firing. And then we go look at the change, and depending on how soon it was rolled out or what the impact it has on the customers, like there, we either just roll it out automatically, or we page the product owners and let them know that the change they're making is impacting and help them address it, and whether they need to just roll it back as well, or if it's a critical feature that needs to be rolled out, then we can look further into optimizing it, maybe as a long-term solution. And then similarly, we got another alert. This one was PagerDuty, and we saw the deployment in downstream dependency, which actually affected this SLO. So in this case, it's not directly the product owners who are rolling out the feature, but it's from the dependencies in the flow, and it would follow a similar process where we check the impact and address it accordingly. But these are just 2 examples, and we have a lot more wins, and usually when we present them, you would include specific service and specific flow and specific number of FCIs and such, which unfortunately we can't show you here. But you can imagine that, just like Jash was saying, some of the 2% revenue impact or number of customers impacted are, like, it really helps us quantify and show the impact that specific changes or specific features have on users, and help us become more resilient and how to prevent these things in the future. Then it's a wrap. Then remember that great observability is like a well-balanced meal. It takes the right ingredients, proper technique, and a dash of creativity. By implementing SLOs for your asynchronous pipelines that represent customer experience directly, you have actionable insights and exactly the impact that you can quantify to enhance your site's reliability and customer satisfaction. And we've shared our recipe today. from selecting the freshest metrics to plating beautiful dashboards. But the best dishes come from constant experimentation and adaptation to your unique environment. So take these techniques back to your kitchen, adjust the seasonings to taste, and serve up reliability that keeps your customers coming back for seconds. Bon appetit to better observability!